right, so now that you're familiar with the graph of y is equal to sine x and cos x, what we're going to do now is transform these graphs. So you have performed transformations already, but on different types of functions. So you are used to looking at this general form here. Y is equal to a times f of b times x minus h plus k. So this by now should look quite familiar to you. Remember, your A and your B caused what we called stretches and reflections. Okay, and finally your H and your K caused what we called translations. Now we are going to take these concepts and put it together with your sinusoidal functions. So I'm going to go to my next slide here. So here's the general form of sinusoidal functions that are undergoing transformations. So here's your cosine function and here's your sine function. Now I want you to notice that we are still working with A and B here, but notice that it's no longer H and K, it is actually C and D. But even though the variables are a little bit different, it doesn't mean that they don't do the same, they do different things. They actually do the same thing. So in this lesson, we're going to focus on one parameter, and that parameter is the A value. So we're going to study in this podcast the effect of parameter A on the graph of y is equal to cos x and the graph of y is equal to sine x. And how we're going to do this is we're going to go into our calculator to see what happens when you change the value of A. So in your calculator, make sure that you're in degree mode. So we're going to graph it using degrees. Go into your y equals and plug in y is equal to sine of x. For your window, I like to use a zoom 7 trig standard. So if you go back, if you go into your zoom window, you're going to select 7 for trig. So select 7 and you're going to get a curve that looks like this. So this is what we call a sinusoidal wave. And it's a wave because, well, if you take a look, it models a wave pattern. So we're going to graph a function where the A value is not 1. So right now, this is the graph of y is equal to sine x. And a few things I want you to notice here. Remember our A value, which is our amplitude, that's 1. Okay, and even down here that's -1, but our amplitude is equal to 1. Now let's see what happens if I change the value of A, meaning I put a number in front of the sine x. So let A be equal to 2. So graph the function y is equal to sine y is equal to 2 times sine x on the same window. So plug in 2 sine x and oh, not 10. Okay, give me a second here. And what I want you to do to that curve is make it look a little thicker. So go all the way to the left and press enter and press graph. And there is the graph of y is equal to sine x. Now notice a few things that changed here. Remember, our x-intercepts do not change when you change the A values. So those values stay the same, but what changed was the amplitude. So I went from an amplitude of 1 to now an amplitude of 2. Okay, and even down here it became went from -1 to -2. And that's exactly what your A value does to your graph. As you change your A value, it changes your amplitude. So I'm going to erase these markings here. The last thing I want to look at is when A is equal to a negative number. So graph y is equal to -2 sine x now. Okay, so y is equal to, and you know what? We'll just plop a negative right in front of this function here. Press graph. There's the original function, remember that? And here's the graph of the transform function. Okay, so the amplitude went from 1 to 2. So my amplitude doubled, okay? And that's where that 2 is coming from. Now that negative value calls what we have identified as before as a vertical reflection, okay? So this point got vertically reflected in the x-axis, and it also got doubled. So that's why it went from a -1 to a -2. Okay, so let's tie this all up here. Let's go here. So what can we conclude here? There's a few things we can. Parameter A causes a vertical stretch by a factor of the absolute value of A. Okay, so in my last example, I caused a vertical stretch by a factor of 2. If A is negative, then there's a vertical reflection in the x-axis. Okay, and lastly, what characteristic change? The characteristic that changes here is the amplitude. The amplitude becomes the absolute value of whatever your A value is. And finally, your domain remains constant and the range changes. So that's it for the effective parameter A on sinusoidal functions.